We usually assume that if a concept is hard to grasp, we must be bad at it. But when we acquire information smoothly and without effort, that knowledge rarely sticks. It tends to collapse into dust as fast as we built it. This cognitive trap is tied to metamemory, our ability to think about how we think and learn. When you sit in a passive lecture and easily nod along to the material, your brain registers that fluency as mastery. Because the information feels readily available in the moment, you falsely assume it is permanently stored. Using this immediate feeling of ease as a measuring stick leads to a critical mistake. We end up misjudging our progress and routinely choosing study methods that feel highly productive over the challenging conditions that actually create long-term retention. The assumption that learning should be a smooth, highly structured process has a specific starting point. In 1851, the Prussian government banned a controversial educational approach created by Friedrich Fröbel, a system he called kindergarten. Prussian authorities worried that Fröbel's playful methods would teach disobedience. In their place, they enforced a strict system of supervised, government-approved instruction. This model deliberately severed the connection between playtime and learning time, establishing the rigid, rows and columns environment we still recognize today. This 170-year-old model established an educational standard where progress was measured by the absence of play. It traded the unpredictable process of discovery for a controlled environment, one that prioritized the delivery of the answer over the friction of the question. To endure the necessary friction of genuine learning, the brain requires a specific physiological primer: curiosity. Curiosity is a distinct neurological state, not a fleeting mood or a fixed personality trait. Once curiosity is sparked, the brain behaves like a vortex, pulling in and retaining even dry, unrelated information. This primed state alters the brain's reward centers. When drawn toward an answer, the subsequent struggle feels intrinsically pleasurable. The effort itself becomes rewarding. If an instructor jumps into providing answers without first provoking a question, they bypass this mechanism. They are no longer just fighting for a student's attention. They are working against the brain's internal reward system. For centuries before modern schooling, children engaged their curiosity through play. Play serves as the original, evolutionary engine of self-directed trial and error. Educators like Maria Montessori capitalized on this by designing highly specific physical materials, like sets of stackable wooden cylinders or tiered blocks. These objects isolate concepts like volume and spatial reasoning, forcing a learner to physically interact with the problem and experience physical failure when a piece doesn't fit. This kind of self-directed exploration provides immediate, undeniable feedback. When our physical assumptions fail, we are forced to adapt, making play the ultimate form of active, rigorous learning. This requirement for friction applies equally to adult learners. Cognitive scientists refer to this as desirable difficulties, the deliberate introduction of challenges into the study process that purposefully slow down your apparent rate of learning. Stimulus fluctuation theory presents a counterintuitive idea. Forgetting creates the capacity for deeper learning. As memories fade, the brain must forge robust associations to retrieve them. Exploit this by spacing out study sessions and generating answers from memory. This effort builds a denser neural framework. That frustrating feeling of struggling to recall a fact is not a sign of failure. It is the mechanical process of your brain forging the connections required for a permanent memory. If the physical architecture of memory requires struggle, then the philosophy of how we educate must match it. True progress relies on ambiguity and the tension of uncertainty, not the rapid accumulation of correct answers. The poet John Keats described an ideal mental state called negative capability. This is the ability to sit in the mystery of a complex problem, embracing the fact that you do not know the answer without anxiously demanding an immediate resolution. The most effective educators design their classrooms around this tension. They introduce a hook, a riddle, or a bizarre fact that cultivates a sense of larger purpose, pulling a student through the discomfort of not knowing. The ultimate goal of education is not to build a frictionless path to mastery. It is to cultivate the courage required to continually seek out the struggle of the unknown.